I hereby open this academic ceremony in which Lorraine Zwienenberg will defend her academic thesis, The Heart-Brain Dialogue, Pathways to TMS Treatment Optimization. May I invite you to present a summary of your study and conclusions of your thesis.
Test, ja. Goed. Oké, welkom allemaal bij de verdediging van mijn proefschrift The Heart-Brain Dialogue, Pathways to TMS Treatment Optimization. In mijn onderzoek heb ik gekeken naar de koppeling tussen de brein en het hart om de behandeling van TMS voor depressie te optimaliseren. En daar ga ik jullie wat over vertellen. Een depressie, jullie hebben er allemaal wel eens van gehoord, verwacht ik. Maar het is een aanhoudende psychiatrische, het is een psychiatrische aandoening, gekenmerkt door een aanhoudende somberheid, verlies van interesse en energie, onder andere nog andere dingen, maar bijvoorbeeld ook verstoringen in het eetpatroon, in het slaappatroon. En mensen met een depressie kunnen gedachten hebben aan de dood, een wens om zelfmoord te plegen of ze gaan daadwerkelijk zelfmoord plegen. En dan kun je je voorstellen dat het superbelangrijk is dat daar goede behandelingen voor zijn. Nou, gelukkig hebben we die ook. We hebben bijvoorbeeld psychotherapie, maar ook antidepressiva. En deze behandelingen hebben eigenlijk allemaal op groepsniveau een succespercentage van 30 tot 50%. En dat is hartstikke mooi. Dat is fijn dat zoveel mensen ervan opknappen. Maar dat betekent ook dat tot 70% van de mensen niet goed reageert op een behandeling. Als iemand dat nou 2 keer heeft, dat ze dus niet goed reageren op een behandeling, dan spreken wij van een moeilijk behandelbare depressie. En onderzoek toont aan dat als mensen dit hebben, dat de kans om te gaan reageren op een volgende behandeling, of goed te gaan reageren op een volgende behandeling, dat ontzettend laag wordt. Dat daalt naar ongeveer 10%. En dat geeft eigenlijk aan dat het cruciaal is dat wij methoden hebben om vroeg in het behandelproces de juiste behandeling te selecteren voor een individu. Nou, een van die methoden is gestratificeerde psychiatrie. En dit is een methode die ik ook toegepast heb in mijn proefschrift. Om deze methode uit te leggen, begin ik eerst bij hoe het nu wordt gedaan, hoe behandelingen nu worden gekozen voor een patiënt. En dat is volgens de one-size-fits-all psychiatry. Wat hier gebeurt is dat alle mensen met een depressie worden behandeld via hetzelfde stappenplan. Via de behandelrichtlijn depressie. Daar wordt dus geen onderscheid gemaakt tussen mensen, dus verschillen worden niet meegenomen. 2 methoden die daar wel naar kijken, naar individuele verschillen, zijn precisiepsychiatrie en gestratificeerde psychiatrie. Nou, het is een heel druk plaatje, maar ik begin bij de onderste, bij precisiepsychiatrie. Wat hier gebeurt is dat er eigenlijk een biologisch profiel van een individu wordt opgesteld. Dus allerlei biologische informatie wordt verzameld. En de behandeling wordt afgestemd op dat biologische profiel van die persoon. Helemaal geoptimaliseerd natuurlijk. Maar voor de psychiatrie is het op dit moment gewoon nog niet mogelijk om dit te doen. We hebben te weinig betrouwbare biomarkers hiervoor. Er zitten te veel haken en ogen aan. En dat is waarom we eigenlijk naar de gestratificeerde psychiatrie zijn gegaan. Wat we hierbij doen is dat we ook kijken naar de biologie van een persoon, naar de biomarkers. En die biomarkers wijzen eigenlijk een individu toe aan een subgroep. En van die subgroep is bekend op welke behandeling zij waarschijnlijk het beste reageren. En het mooie is dus dat je op deze manier altijd kiest tussen behandelingen die wetenschappelijk bewezen zijn voor depressie. Dus je kunt niet fout kiezen. Een van de behandelingen die wetenschappelijk bewezen is voor een moeilijk behandelbare depressie is TMS. En TMS staat voor transcraniële magnetische stimulatie. En nou weten jullie allemaal precies wat die behandeling inhoudt. Ja. Wat er gebeurt bij TMS is dat er een magnetische spoel is. Daar komt een magnetische puls uit. En als je die spoel op het hoofd plaatst, dan gaat die puls door de schedel heen de hersenen in, waar het in de onderliggende hersengebieden de hersencellen kan activeren. Nou, als je dat maar vaak genoeg doet, dan kan dat een therapeutisch effect hebben. En dat betekent in dit geval dus dat de depressieve klachten afnemen. TMS voor depressie heeft ook een succespercentage van 30 tot 50%. Dus ondanks dat die mensen eerder niet hebben gereageerd op minimaal 2 behandelingen. Waar op het hoofd stimuleren we? Dat is de dorsolaterale prefrontale cortex, afgekort de DLPFC. En dat is het hersengebiedje hier vooraan. Dat kan dus zowel links als rechts. Dat hoef je niet te onthouden, maar dan weet je wat de DLPFC, wat ik daarmee bedoel. Als we dan kijken naar de stimulatie op de DLPFC voor depressie, dan zijn er nog weer verschillende behandelmogelijkheden. We hebben bijvoorbeeld verschillende manieren om de DLPFC te lokaliseren op het hoofd. En bij CINEDA, dus waar ik werk, gebruiken we vaak de beam en 5 centimeter locatie. Dat zijn ook de methoden die ik in mijn proefschrift gebruikt heb. De beam locatie zit wat meer vooraan, terwijl de 5 centimeter locatie daar ongeveer 2 centimeter achter zit. Verder zijn er verschillende stimulatieprotocollen. We doen bijvoorbeeld rechts het trage protocol en links het wat snellere protocol. En verder kijkt onderzoek naar verschillende pulsvormen, verschillende stimulatieintensiteiten. En deze dingen zijn dus allemaal wel wetenschappelijk goedgekeurd, maar wel verschillend. En ondanks die verschillen hebben we dus wederom een succespercentage van 30 tot 50%. Dat suggereert dus eigenlijk dat er verschillen zitten tussen mensen. De een reageert beter op deze behandeloptie, de ander reageert beter op de andere behandeloptie. En wij willen dus eigenlijk die verschillen tussen personen in kaart brengen door middel van die biomarkers. En dan dus kijken, oké, die biomarker zegt dit, kunnen we dan een persoon toewijzen aan de voor hen meest optimale behandeloptie. Ik hoop dat dit duidelijk is. Een belangrijke biomarker in mijn proefschrift is de hartslag. En dat is onder andere omdat een depressie vaak gepaard gaat met een hogere hartslag, een lagere hartslagvariabiliteit. Dus in het algemeen een verstoord autonoom zenuwstelsel. En welke biomarkers heb ik nou gebruikt? De eerste is de Heartbeat Evoked Potential, afgekort de HEP. Als je hart slaat, dan heb je altijd zo'n piekje in het hartslagsignaal. Als je naar het hersensignaal kijkt op hetzelfde moment, dan zie je ook zo'n piekje. En dat is de Heartbeat Evoked Potential. En deze is verschillend bij mensen met en zonder een depressie. En daardoor super interessant voor ons om naar te kijken of we daar informatie uit kunnen halen. De tweede biomarker is hart-brein-koppeling. En dit is een methode die we zelf ontwikkeld hebben, afgekort HBC. En bij deze methode maken we gebruik van de overlap van het depressienetwerk met het frontaal-vagale netwerk. En dit netwerk is gekleurd in de afbeelding. En heel simpel gezegd, als we die DLPFC stimuleren en dat netwerk wordt geactiveerd, dan zien wij een hartslagdaling. Nou, hoef je ook weer niet allemaal te begrijpen. Maar als die hartslag naar beneden gaat tijdens stimulatie, we zien dat die hartslag weer normaliseert als we stoppen met stimuleren. Dus dat wekt een specifieke ritme op tijdens de verschillende stimulatieronden. Dat ritme kunnen wij meten en dat noemen we dan hart-brein-koppeling. En de derde en laatste biomarker, deze is niet specifiek gerelateerd aan de hartslag, voor zover ik weet. Maar dit is de individuele alfa-piekfrequentie, de IAF. En dit is informatie die halen we uit het hersensignaal. Het hersensignaal bestaat uit verschillende snelheden en wij kijken specifiek naar de alfa-golf. En van die IAF is bekend dat het een stabiele biomarker is om patiënten toe te wijzen aan verschillende TMS-protocollen. En dan bedoel ik dus ofwel dat tragere protocol rechts ofwel dat snellere protocol links. Wat heb ik nou eigenlijk onderzocht? In hoofdstuk 2 beschrijf ik mijn eerste onderzoek. En hier heb ik eigenlijk gekeken of de Heartbeat Evoked Potential een voorspellende waarde heeft over de behandeleffectiviteit van 4 verschillende behandelingen. En dan heb ik gekeken naar 3 typen medicatie en de TMS-behandeling. Wat ik heb gevonden is dat mensen met een hogere Heartbeat Evoked Potential beter reageren op de TMS-behandeling, terwijl mensen met een lagere Heartbeat Evoked Potential beter reageren op venlafaxine. Nou, dat is een type antidepressiva. En dit betekent dat als iemand bijvoorbeeld 1 of 2 behandelingen heeft gehad en je niet helemaal weet wat gaan we nou als vervolgstap doen, dan kun je kijken naar die heartbeat evoked potential en dan kun je zeggen, oké, heb je hoog, nou gaan we naar TMS en anders naar de venlafaxine. En zo kun je misschien een behandelstap overslaan. In hoofdstuk 3 heb ik gekeken of die hartslagdalingen die ik net noemde, of we die ook zien bij mensen met een depressie. Want tot dat moment was het alleen nog maar bevestigd bij gezonde proefpersonen. En lang verhaal kort, als je kijkt op de afbeelding naar de 2 blauwe locaties. Dat zijn de locaties waar de meeste hartslagdaling zichtbaar is. En dit is precies hetzelfde bij gezonde proefpersonen als bij depressieve patiënten. En dit is natuurlijk cruciaal om de vertaalslag te maken van onderzoek naar de klinische praktijk. In hoofdstuk 4 heb ik de hart-brein-koppelingmethode gevalideerd, gerepliceerd en geoptimaliseerd. Over dit artikel is heel veel te vertellen, maar de optimalisatie die gaat voornamelijk over de ontwikkeling van een stabiele frontale drempelwaarde. Dat vereist wat extra uitleg, denk ik. Ik heb het eerder gehad over hoe hard het apparaat moet staan om daadwerkelijk de hersenen te bereiken. Dat meten we bij elk persoon, want dat verschilt per persoon. Maar dat meten wij op de motorcortex. En die motorcortex loopt van je oor tot aan het midden van je hoofd. Beide kanten op. En daarin zit eigenlijk alle bewegingen van je lichaam gerepresenteerd. Als je nou op de plek van de hand stimuleert op de juiste intensiteit, dan ga je zien dat die hand beweegt. En dan weet je, we zitten in die hersenen. Maar goed, wij stimuleren voor depressie niet op de motorcortex, maar op de DLPFC. Dus wij wilden zo'nzelfde feedbackmechanisme ontwikkelen voor de DLPFC. En dat is gelukt. Wat we gevonden hebben is dat die drempelwaarde op de DLPFC lager is dan die op de motorcortex. En dat betekent dat we misschien in de behandeling voor depressie te hoge intensiteit stimuleren. En dat het dus misschien wat lager kan. En als we lager stimuleren, dat kan leiden tot minder bijwerkingen. Misschien zelfs tot een effectievere behandeling, omdat het gewoon beter toegespitst is op het individu. Daarnaast ook nog belangrijk, we hebben uitgesloten dat pijn van stimulatie, want je voelt het best wel als je de puls op je hoofd hebt. We hebben uitgesloten dat dat gevoel van invloed is op de hartslagwisselingen. In hoofdstuk 5 beschrijf ik het onderzoek wat ik heb uitgevoerd in Oxford. Even kijken, in te ver. Op de afbeelding zie je 4 pulsen, TMS-pulsen van 4 veelgebruikte TMS-apparaten. En wat je hier eigenlijk ziet is dat ze niet allemaal hetzelfde zijn. Dat spreekt denk ik voor zich. Deze verschillen zijn wel onderzocht op de motorcortex, wederom, maar niet op de DLPFC. En ik heb ze dus getest op de DLPFC. En wat ik heb gedaan, of wat ik heb gevonden, is dat kortere pulsen effectiever lijken dan langere pulsen. En daarnaast zijn de verschillen groter op de DLPFC dan op de motorcortex. En dat betekent eigenlijk dat die verschillen dus nog belangrijker zijn om mee te nemen als we het hebben over DLPFC-stimulatie dan motorcortex. Goed, laatste hoofdstuk, laatste onderzoek. In dit onderzoek hebben we eigenlijk, dit gaat allemaal over de patiënten bij Cineda. Dus het zijn allemaal patiënten die aangemeld zijn voor de RTMS-behandeling. En die heb ik eigenlijk toegewezen op basis van hun hersensignaal, dus die IAF. Toegewezen aan ofwel het trage protocol rechts ofwel het snellere protocol links. En op basis van hun hartslagmetingen aan die beam of die 5 centimeter locatie. Dus we hebben de behandeling best wel veel meer geïndividualiseerd. Het idee was om het ook te optimaliseren. En wat we hebben gevonden is dat zowel patiënten als behandelaren tevreden waren met de implementatie van deze methode. Wat al een mooie bevinding is. Daarnaast blijken de IAF en de hart-breinkoppeling onafhankelijk van elkaar iets te zeggen over waar we op het hoofd het beste kunnen stimuleren. En heel voorzichtig zeggen we dat het lijkt te kunnen leiden tot een effectievere behandeling. Maar we hadden daar eigenlijk net een beetje meer data voor nodig. Dus we zijn nog steeds data aan het verzamelen. Goed, de conclusie. Gestratificeerde psychiatrie kan absoluut bijdragen aan het optimaliseren en individualiseren van de TMS-behandeling voor depressie. Hiervoor lijkt de hart-brein-connectie een hele waardevolle biomarker. En ik denk dat er veel meer onderzoek nog gedaan moet worden naar de hart-breinkoppeling. En in het algemeen is het gebruik van biomarkers en gestratificeerde psychiatrie een mooie manier om de kloof tussen onderzoek en dus de praktijk te overbruggen, zodat patiënten gewoon veel eerder kunnen profiteren van de nieuwste onderzoeksbevindingen. Then I give the word back to the prorector.
Yes, thank you very much for your very on-time presentation. So the opposition will now be opened by the chair of the assessment committee, Professor Dr. Bernadette Jansma, who is holding a chair here in cognitive neuroscience of language processing here at Maastricht University.
Yeah, thank you, Prorector. Dear candidate, first of all, apologize that I speak in English, but that's due to the international guests also. But I would like to congratulate you and also your supervisors to this work. I enjoyed reading this very relevant clinical work with great interest and fascination. Especially, I think you elevate the scope of going outside the brain into a connection of body parts and the brain here, the heart. And I think there you show a great moment of pioneer spirit and bravery actually to go there. And I think you can be really proud. But of course, I also have questions. And one relates to the rationale of actually focusing on individual alpha frequency, right? So when I do EEG, and we do it a lot with children and adolescents and grown-ups, and I would do a spectrum, it's very easy to see the individual alpha because it goes out of the spectrum as a peak. The problem is that all other frequencies I cannot clearly see in an individual. So a sort of mean question is, are you focusing on individual alpha simply because you can see it well?
Highly esteemed opponent, thank you very much for your kind words and your interesting question. So, short answer, no. We're not only looking at the individual alpha peak frequency because it's easy to see. There's a lot of previous research that looked into the IAF, and it shows that there is it's actually promising. There were a lot of replication data sets that actually showed that remission rates went up if you retrospectively stratified based on the IAF. So
yes, no. It's fair enough, and you mentioned already that you base, of course, your work on previous work, but there's also other work in terms of relevance of frequencies in major depression. So, and I'm not an expert, so you can also correct me if I'm wrong, but I read once that when you have this type of problem, you also hyper-monitor. So when you think a lot about your self-image and so on, and people have shown that this hyper-monitoring or the elevation of hyper-monitoring is related to theta. So that's not alpha, that's a lower frequency between 3 and 7 hertz. So what is your view on the role of theta in major depression, and how would you tackle that using TMS then?
So I'm not an expert on theta at all, but I can imagine, because of its role in executive functioning and in general, that it's absolutely related to depression, but I'm just not sure if it could be a predictive biomarker, stratification biomarker, or anything, but yeah. I think that's all.
It's fair enough. And the same, of course, here it comes would be related to beta, because you at your I think in the introduction, very nicely, in page 25, you describe this interaction between the dorsolateral prefrontal cortex and this SG anterior cingulate cortex. You also say it's very relevant that they are anti-correlated, which, by the way, for me is a funny term. So because when I talk about correlation, it's either positive or negative or zero. But what does anti-correlation mean then? Could you explain that?
So in this case, it means that once the DLPFC, if I'm correctly now, but if the DLPFC is activated, you will see a response in the ACC, subgenual ACC, which decreases activity. So it's more of, is it a negative correlation? I'm not sure, but it's an anti-correlation.
Yeah, but that's good. So you have the knowledge. That's great. Yeah. But then back to my question, if I may. So beta would be like higher than alpha, but also people have described this interaction between these areas as being beta-driven. So why then again do you focus on alpha when actually other frequencies might also be relevant in network characteristics and hence also be relevant in the disorder?
So in my case, it's just that we're working based on previous research. I'm not excluding that the beta or theta can also be used, but in this case, we just chose to go with the alpha.
Yeah, fair enough. Makes sense. Thanks a lot.
Thank you.
Yeah, thank you. So the opposition will now be continued by Professor Bart Drton, who is also a member of the assessment committee. He's joining us online, but he is in reality here in Maastricht, holding a chair in psychiatry. Bart.
Thank you very much, Mr. Prorector. Can I be understood like this? Things work? Yeah, okay. So first of all, my congratulations and compliments to you, candidate, because this has been a wonderful thesis. It's really a set of studies with a holistic approach, incorporating physiology with psychology and psychiatry. It's very readable. And I also enjoyed the clinical vignette of Eileen that you introduced in the beginning, and you also discussed the clinical case as well. So also showcasing that you are working as a clinician with academic knowledge. So I really enjoyed reading it. I also found it visually attractive. So the cover was beautiful, but you didn't make it. I think Mark Koppenberg has to be applauded for this. And also your promotion team, I would like to provide the compliments. First of all, I want to start with the cover because there was I'm not really sure whether you can see it. There's a small meteor on it on the left-hand side. I was wondering what does it do on the cover on this wonderful artistic thesis. So please, can you comment on this first? Then we can continue.
Thank you very much for your compliments, kind words. And your very unexpected question. I'm wondering the same thing, but I hope it will come out with a bang. I'm not sure how to say it in English, like a meteor.
I was promising the impact that your thesis defense would have, I was thinking. It's a big impact that this field has on the clinical psychiatry. So, okay, that's a nice illustration of that. Okay, then we go into the booklet itself. I would like to ask one of the paronyms to read proposition number 1. Aloud, please.
Yes. After one failed first-choice treatment option, the heartbeat evoked potential could be used as a stratification biomarker to choose between venlafaxine and TMS as the next treatment option.
Yes, thank you very much. So that's in chapter 2, as you also indicated there. And I like these types of propositions because that we can discuss on what you say. So I went to chapter 2, to page 40 and 41. I would like to bring you there as well. So if you have a booklet there, you could maybe open it. because you based this proposition on the findings that you present on page 41. And I was reading the statistical analysis or the design of it that you also describe on page 40. And I was wondering, is this really a good basis for this proposition? Because if I can read aloud, and this relates to the question I have on multiple testing, because you write there, the repeated measures ANOVA on the N8 peak yielded a significant between subjects remission treatment effect with a p-value of 0.045. And then you also analyzed things for the groups. For the venlafaxine group, you found a p-value of 0.049. And if I see these p-values, always a bit skeptical, you know. So it's just at the borderline as what we call statistically significant. And you have one test and a finding is below 0.05, then we can call it statistical significant. But you report on findings on the N8 peak, but also on findings on the N270 peak. So 2 tests you do. And I was wondering, did you correct for multiple testing, doing 2 tests or analyzing them both and reporting them both? Did you correct for this? And if yes, how did you, or if no, how would you cover it? And if yes, how did you do it?
So if I understand correctly, you're asking if we corrected for the multiple testing in a repeated measures ANOVA, right?
Yeah, but you do 2 times. So you do 1 peak on N8 peak and 1 analysis on N270 peak. So effectively, you do 2 tests, and then I think you should also divide the p-value by 2. So 0.05 should then be 0.025 before it becomes statistically significant. Now, it seems to be like a detail, but sometimes it isn't because you base your proposition on the statistical significant difference between the venlafaxine group and the other ones.
Yeah. So no, we did not do the corrections for multiple testing. And that's basically because we actually saw it as 2 different analyses. It's 2 different data sets. So I assumed that this was the way to go. And I absolutely understand your concern with the p-value of almost, well, non-significant. However, if you look at the effect sizes, it is a quite, well, I would say big. I think officially it's a medium effect size. But if you look into that, then yeah, I would say we can still say that the heartbeat evoke potential could be used as a stratification biomarker. And that's also mainly because statistical significance within the stratification is not most important. It's a way to help us understand the data. But it's in this case, it's a 2-way thing, and with stratification towards the one, you have a higher chance of responding to treatment, whereas if that person would be stratified to the other, it would be a lower chance. So does it really matter then if it's significant or not?
I would think it may do. It may make a difference. Anyways, I will leave you with this on this point. So thank you for that answer. I would recommend maybe, I think you or maybe your wider team is doing this. So if you find something, it's always good to try to replicate the findings. So probably that is on the way, and that you can really see the robustness of these findings. But thank you for addressing that question. A second question I have is more a conceptual one, and it relates to things that you introduced in chapter 1 and that you discuss in chapter 7. It's about stratified psychiatry towards personalized psychiatry. And maybe I think what we're trying to reach also is a not only personalized, but also contextualized. A person is always in a certain context, also when people receive the TMS treatment. So they are in a given clinical setting, and they're also, and that is my question, in a certain affective state or a certain arousal state And I was wondering, has this been measured during your experiments, that you measure the arousal state or the stress state or the affective emotional state at which people receive the treatment? That's the first question, I think.
I think it's a very good point. We did not measure brain state, arousal state, emotional states. But yeah, we do know that it's super important, brain state dependence and everything. So in future studies, I would be super interested to include it. But in this case, we sadly didn't. Nope.
Okay. Many thanks for this clarification. I would like to give the word back to the prorector. Thank you very much.
So we continue the opposition with the third member of the assessment committee, also joining us online, Dr. Diego Canya Rivera, who is an expert in brain-heart physiology at the Paris Brain Institute at the Sorbonne University.
Thank you. Congratulations, Lauren, for this work, and congratulations as well to your team. So with all these new methodologies, the main question that can rise is, why is this happening? We speculate about some of the mechanisms and what is really happening in the physiology. So I have a couple of questions for you about that. First, in the chapter 2, so you found differences in the heartbeat evoked potentials in these patients remitting from the venlafaxine treatment. So you mentioned very few words about what could be possibly happening, especially in the scalp location where you find these results. So could you tell me a few more words? What do you think is happening in this, even if it's minor or marginal statistical difference? What do you think is happening in the brain-heart axis and in these patients? And what would you add if you can actually redo the experiment, for instance? What would you add to be sure on what is going on?
Deemed opponent, thank you very much for your compliments and your question. I didn't get everything you said, I think, because of the connection. However, I think that you're asking whether what's the underlying mechanism of why I expect to find something with the venlafaxine instead. Yeah. Okay.
Yeah.
Good. So. Yeah, it's what I wrote down. Venlafaxine is an SNRI, so it works on the noradrenergic system. I think, it's not quite my expertise, but I think the somatosensory cortex is also one that's mostly innervated with the noradrenergic system. So that would makes sense that the venlafaxine is coupled to this effect, and this is also because the heartbeat evoked potential is mainly thought to be related to the somatosensory cortex. So I would say that is why it makes sense that we found this relation. Did I answer your question enough? Because I thought you had a second one, right?
Do you think this could be linked to somehow what you present in the next chapters with the frontal vagal pathway, or do you think it's a completely different story here?
Well, maybe, but as far as I've read the last few weeks, I think the heartbeat evoked potential is mostly related to blood pressure and baroreceptor functioning. So I would say, yeah, that there could be a relation with the frontal vagal pathway, but I'm at this point not quite sure how that would work. So I would say it's possible that they're somewhat separate. Okay, so maybe not. Maybe it's also through the vagal nerve or anything related with, of course, with sympathetic, parasympathetic activation, that it could work through the frontal vagal pathway. But yeah.
Would you do other kind of measurement to be sure on that? Would you measure something else apart of EEG and ECG to be sure of what is happening? What would you include in your measurement if you will have to replicate this experiment?
Definitely focus on recording blood pressure because it's correlated, and I think it's not possible to acquire a true heartbeat evoke potential without ruling out the effects through blood pressure, although they are related. But I would say that that's something I would really do differently in a future study.
Okay, and I have also a related question, but related to the later chapters on the TMAs and your brain-heart coupling. So you mentioned throughout the chapters that what you're targeting here is the frontal vagal pathway. So I wanted to develop on what are your pieces of evidence that confirm you that is actually what you're targeting with the TMS, if it's actually the frontal vagal pathway. And I do this question because what you use as a brain-heart coupling measure is heart rate variability in 0.1 hertz, which is typically associated to more sympathetic.
I didn't quite get the last part of your question, but regarding the evidence that we have for activating the frontal vagal pathway, so my colleague next to me, she did a study in which they looked at the anti-correlated side, the correlated side, and a neutral side, and then they were able to detect the anti-correlated side by using heart-brain coupling, because the one with the most heart-brain coupling also was the one who was anti-correlated. So I would say it's not a direct evidence, but it sure suggests that we're onto the right pathway. Also, the thing regarding to pain of stimulation, you would expect if you feel pain that the sympathetic system would be activated more than the parasympathetic. And it's not what we see, so it doesn't make sense if it would be anything else, I would say. But it would be amazing if we could do the TMS stimulation in an MRI and then see if the pathway actually gets activated. So maybe someone could do that.
I have a last question if there is time.
A very short one.
So one of the biomarkers you are using to compare is individual alpha frequency. So one can speculate that one of the reasons is because is to account for individual differences between the brains of the patients. Would you propose an individualized measurement based on the heart or brain-heart coupling?
Sorry, are you asking me to choose between heart-brain coupling and the alpha peak frequency?
No.
Oh.
So if individual alpha frequency seems informative sometimes, how would you consider individual differences in heart analysis?
Oh, sorry, I really don't understand the question.
Do you think considering individual differences on the hearts of people, our hearts have different size, for instance, they pump a different amount of blood. Do you think that considering these little differences will make an improvement on analysis like we do with the individual alpha frequency?
that absolutely might be interesting to look at, but at this point, I don't know. Might be interesting. Yeah.
Okay.
Thank you.
Thank you.
Thank you. So we now continue the opposition with Professor Dr. Pim Drinkenberg, who is Chair in Translational Neuroscience for Psychopathology at the Rijksuniversiteit Groningen. The floor is yours.
Thank you, Mr. Pro-Rector. Allow me to first thank the University of Maastricht and the supervisors especially for providing me the opportunity to discuss this very interesting PhD thesis today. I'd like to compliment the supervisors for sure with this great body of work, but also you, dear candidate, the way you put down in this appreciated thesis. Well, I'm definitely a fan, or at least a dedicated follower of the scientific work that's done at CINEDA and at the brain clinics. I do like to discuss some topics with you, or maybe even some conceptual issues, for which I'm sure that you can teach me and explain about this new research field. And when I see a PhD thesis with propositions, I'm always getting a bit heated up already, because that usually are those things that the PhD candidate are very close to the heart, or I should say maybe heart and brain here. So the one that caught my attention was proposition number 7. So if I may ask you to read it out loud.
All psychiatric disorders may originate from a common underlying source, with their diverse manifestations being shaped by individual, biological, psychological, and environmental factors.
Well, thank you for that one. It gave me some thinking, actually. For many years, I had the privilege to do research at the causes of affective spectrum disorders, including depression. But I have to say that was mostly with an emphasis on pharmacological treatments. And I would say also there, we always try to find the common cause, the common underlying cause. Needless to say that we didn't succeed thus far. But since you have this proposition, I would like to ask you to give your view, please, on what could be the source that we all want to know. Are we talking here just about semantics, or should we think about genetics or epigenetics? Please explain.
Highly esteemed opponent, thank you very much for your kind words and your interesting question regarding the proposition. So no, it's not all semantics. Also in my mostly in my experience with treating patients, and of course my knowledge on what I've written, and I would say that every person with a psychiatric disorder has some deviations in their autonomic nervous system. So something goes wrong, it's sympathetic, it's stress, it's everything. And I think that the problem there just comes out in every person differently. So one person is going to avoid feeling, gets depressed. Someone is turning all their attention towards everything that's happening inside. Anxiety happens. Well, I can go on, but that's mostly how I look at this. So I hope that answers your question.
Yeah, I'm still looking a little bit into the commonality of that, apart from the fact that there's a disturbance in the autonomous system. But I would like to ask you to discuss another suggestion that I came to my mind, and that's based on 3 things that you wrote in your thesis. The first is with respect to the fact that in one of the key findings in depressed patient, you noticed that heart rate goes up, heart rate variability goes down.
Yeah.
Is it possible that all your findings with that respect are related to disturbances in vigilance? So are we talking in general about vigilance control issues? I mean, there have been for quite some time, some interesting theories about how vigilance disturbances and control is related to depression. And so that's one point where I see, I'm not suggesting that TMS effects are exerted through vigilance per se, but maybe they share partly underlying mechanisms or networks, so that would be the first bit that you mentioned. The second bit is that on page 154, you mentioned that EEG frequency bands, and then you refer to delta, alpha, beta, theta, that they correspond to resting states. So again, resting states, vigilance related. And you even advert for them that they are the most promising markers for vagal modulation. So another indication that there may be an underlying cause with respect to vigilance. And then the third and last point, and that's also something from your thesis, I guess that you refer to the work of Drton et al. In 2019, who says that prefrontal delta oscillations, they trigger cardiac vagal control and on the cardiac rhythm. So if you see that the promotion of these delta oscillations is most promising EEG frequency, and we know that there are many antidepressants who actually have a direct effect on vigilance and especially on sleep and on delta, is that not yet a third reason to think about that maybe we should look at vigilance as an underlying cause? Can you discuss your findings in that framework?
Okay. First of all, can you please translate vigilance, just to be sure, to Dutch?
Vigilance.
Or explain it in, of course, but just to be sure that I'm actually answering the questions correctly.
Vigilance, you could say, it's the level of arousal.
Yeah, okay, so yeah, I got that. Okay, so 3 questions. The first question, vigilance in general. Yeah, I could think that vigilance is related to depression, of course also to anxiety. In clinical practice, we often use the window of tolerance, which is immensely related to vigilance then. And then the relationship to delta. Sorry. Delta and the heart rate. It's quite an extensive question.
I can try to simplify it.
Maybe, yes, please.
You mentioned the autonomous nervous system,
yeah.
Sort of the common source, which I think is very interesting starting point for discussion. So I add to that maybe you can take it one level further and say it's vigilance control rather than the autonomous system.
Yeah, that's absolutely possible. It's also depending on what your attention is focusing on. Is it inward? Is it outward? Is it too much stress that your vigilance is going down? Autonomic nervous. I think they're super related. Yeah. So more vigilance, I think, is more of a word. Well, I wasn't quite sure if it was the right word, but that we use, and otherwise it's more a biological system.
Okay. Thank you.
Yeah. Sorry. Thank you.
Okay. Thank you. So now let's continue the opposition with our third external guest, Professor Dr. Marie-José Vantol, who is Chair for Cognitive Neuropsychiatry at the University Medical Center Groningen.
Thank you very much. Dear candidate, I would like to start by complimenting you on a very nice thesis. I've learned a lot from reading it. I usually go through a thesis as a Sherlock Holmes, trying to really understand and put things together. And I think that's also a good opportunity for an academic to get stimulated again and think about fields that are not your own. I think you explained that very well. I'd also like to thank you, and I follow you in you thanking you for this work. I think it was a very fun end of acknowledgement. So without you, I wouldn't be here. So thank you. What I would like to discuss with you, and I follow Professor Rutte also in saying that a strong proposition is a good one. So I don't know if your paranymph is already tired, but please, could you read out proposition number 2?
To improve TMS treatment outcomes, we should let go of the evidence-based TMS locations and fully individualized TMS target sites.
Thank you very much. And that follows that is based on chapters 3 to 6. And I find that a rather bold statement. You're very confident. And I would like to question if you can be that confident. Because if I'm correct, chapter 3, 4, and 5 do not study treatment outcome. And chapter 6 does, but there it's difficult to say, especially based on the figures you present, that there actually is a beneficial effect. So I'd like to ask you, do you think that this statement still holds? Can you say that we can already let go of evidence-based treatment, or is that a bit too early, and was the statement a bit too teasing?
Highly esteemed opponent, thank you very much for your compliments and your interesting question. So I agree that it is a very bold statement. However, I also still stand by it because if you're looking at the different stimulation sites that are currently used, and most of them are around the grid, in a grid around the beam location. All the research shows that it has a similar response and remission rate. So regarding that, maybe we shouldn't go and look for parietal sites or anything, but if we're in a grid around the beam, so the LPFC, I wouldn't say we can't go wrong there.
But then you actually say that we should stay to the evidence, namely that right dorsolateral prefrontal cortex stimulation at beam site is quite good.
Yeah, but I think the grid it's quite big. So there are clinics that are using more inferior sites or that. I think the most important thing is that with stratification, we're always trying to go for an evidence-based option. So as far as we're going with that, yes, we could, and then decide which one is the best. And then hopefully we will find some very good evidence in the upcoming years with which we can prove either that it doesn't matter where we stimulate as long as we're in the frontal vagal pathway, or maybe it's end, that are most, the target site showing most heart-brain coupling is also the one that's mostly anti-correlated to the SGACC, because that is also already shown to be the best stimulation site.
So I'd like to focus with you a bit on the table you presented on page 127. I had a bit of trouble making sense of it because in your presentation you also mentioned you only included CINEDA as a site, but it seems that you included more people also at different sites, so that's a bit confusing, but you base your main conclusions based on the prospective CINEDA sample, if I'm correct, because there you report a 40.9 response rate, for example, as or the remission rate. If we then compare that to the treatment as usual, then it indeed is a bit better, especially when we look at response. And I think that has to do with that the response, if we look at figure 6.5, is just above the threshold of remission in the treatment as usual sample. And what I was curious about is how did it go? Because you clearly are an expert in running a clinical study within the clinics. How did you inform people about the study? Because I can read that people agreed to sharing the data, but I'm not sure if they agreed on being stratified to one of your treatment options, and if they did not, if that would result in a tau treatment. So can you say something about that?
Yeah, of course. So within CINEDA, we started doing this stratification approach. So it was part of started as treatment as usual, the new treatment as usual. However, all the patients were informed that we could either choose the beam site or the 5 centimeter site by throwing a dice, or just random picking, or that we could use their heart rate and bodily measurements to see if we can actually make it better for them. However, that it was a chance, that it's not sure, and they all agreed.
Okay, because if I may shortly follow up, the people in the tau sample as a control sample, they were not kind of offered this, maybe we can do better than this. So this is very special, sorry. We will treat you differently. Do you think this effect of participating or the foresight of maybe even, you also mentioned people like the EEGs, etc. Could that explain part of it?
Yeah, of course. So the treatment as usual, which is presented in as it is presented in the study, was were patients treated from 2014 to 2022. Yeah, 22. So they didn't have the option. We just always went with the same protocol. Okay. And yeah, of course, I'm a big fan of placebo effect. It would be sad, but also if it works, it works. But it would be super important to make sure that in future studies we can rule this out. Yeah, okay. Good point.
I give the word back to the prorector.
Thank you. Now we continue. I expect may conclude the opposition here today with Professor Dr. Theresa Schuman, Professor of Clinical Neuromodulation here in Maastricht.
Thank you, Prorector. Yeah, I also want to start with congratulating you for this fantastic thesis. I think it was quite impressive to see that you work with healthy people, but also try to translate this in the clinic and really try to figure out how does this work in a real life setting. So I think this is really important data. I was also impressed to see that you already have 5 publications. That's amazing for a PhD. And I'd also like to congratulate, of course, the supervisory team. I have a few, maybe some specific questions about chapter 3, because that was a letter to the editor, so I know you cannot put all information in there because it has to be very short. But maybe we can briefly start off with, because I didn't understand a few things. So your title is a neurocardiac guided RTMS as a stratified method between the 5 centimeter and beam F3 stimulation clusters. You didn't stimulate the left side though, right? Not beam F3, but actually F4, is that correct?
Highly esteemed opponent. Thank you for your compliments and your question. So we, I'm a bit lost. So I actually used data that was already
So I think it was all on the right side. That's
yeah, because there were no laterality differences found. Was it right side though? Yeah, I think it was right side.
So then, also something I didn't fully understand. So you use the beam F4 point then, which is of course defined by the software. And your 5 centimeter rule, I wasn't sure, do you actually use FC4 then? Or do you really use the 5 centimeter rule as in that you measure motor threshold and then you go 5 centimeter anteriorly? That wasn't clear to me.
That's a very good question. I believe that, I'm not 100% sure. I believe that they used an EEG cap, so that would be FC4. I'm not 100% sure.
So I also think so, but that surprised me a little because the 5 centimeter rule is already a quite individualized site, right? Because you look for the individual motor hotspot and then you use the 5 centimeter rule. So would you have expected different results if you have actually gone for the 5 centimeter, individual 5 centimeters rather than the EEG side?
That's possible, yeah, because we do see very site-specific reaction, so that could very well be. Yeah.
And then, so you compared these 2 sites, so sites that we generally stimulate, 5 centimeter or F3, F4, whichever, and you found a deceleration in the F4 stimulation side, but also in the 5 centimeter side. And was that different, because I didn't fully understand that. So is it that in some patients or in some healthy people, healthy people, I'm not sure.
This was depressed. Yeah.
This was depressed, sorry. In some patients, you found this deceleration only in the F4 side, and in others only the 5 centimeter sides, because the figure kind of looked as if it was for both.
Yeah. So it was, so the figure represents the most heart rate deceleration. However, it is super individually dependent. So for some people, it's only 5 centimeter only beam. Some patients didn't have it at either, but did have at F2.
I think you may finish your question.
Okay.
Yeah,
some patients did have it F2, not those two sides, so it's completely dependent. But the most people had the most heart rate deceleration at those two sides.
Okay.
Yeah.
Thank you.
Thank you. Lorraine Zwienenberg, the time appointed for defending your thesis has now passed, so the degree committee will now withdraw to discuss the quality of your thesis and your defense, and I request that you and your company here shall stay in the room until we return from our deliberations.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Long road to the south side. 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. The line, I know you know that I can't read your mind. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile. Long road to the south side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Take the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. And even though these nights seem long, I know that I am never on my own. Know you've won the battle once you've grown. South side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. Long road to the south side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. Years can't fly by now, don't waste all your time. Cause I'll go the extra mile.
Hi. Now, Zwienenberg, the degree committee here present has assessed the quality of your thesis and your defense. And in view of its positive verdict and taking into account your previous qualifications, the committee has decided to grant you the degree of doctor. So Professor Zack, your promoter, is now authorized to confer upon you this academic distinction in accordance with Dutch university custom, and I invite your supervisor to now take the floor.
Belooft u dat u altijd volgens de beginselen van wetenschappelijke integriteit te werk zult gaan, eerlijk en zorgvuldig, transparant, onafhankelijk en verantwoordelijk?
Ja, dat beloof ik.
Krachtens de bevoegdheid ons door de wet toegekend, volgens het besluit van de commissie hier tegenwoordig, verklaar ik hierbij u, Lauren Zwienenberg, tot dokter te bevorderen en u alle rechten te verlenen die daaraan volgens wet en gewoonte zijn verbonden. Ten bewijze hiervan overhandig ik u nu de bul, door rector, secretaris en overige leden van de promotiecommissie ondertekend en met het grootzegel van de universiteit bevestigd. Ja, gefeliciteerd, Dr. Zwienenberg, Lauren. Voor ik het woord aan Hanneke geef voor jouw laudatio, wil ik jou ook heel erg danken voor de samenwerking. En ook Martijn en Hanneke inderdaad voor de samenwerking. En Sineda, die hier ook weer aanwezig is voor die heel leuke samenwerking met Maastricht University en Brain Clinics en Sineda. In de afgelopen jaren is dat echt een ongelooflijk succesverhaal wat promoties betreft, publicaties en ontzettend boeiend ook voor ons en mijn groepje in Maastricht onderzoek te doen die zo dicht bij de patiënt is en zo'n verschil kan maken echt in het leven van de patiënten. Dus we zijn er heel blij mee met het onderzoek, met jou, met die samenwerking. En een kleine persoonlijke opmerking. We hebben een aantal keren natuurlijk de laatste 4 jaar contact gehad, over dingen gesproken. En ik vond je altijd een heel verfrissend, authentieke persoon. Je bent gewoon heel uniek, Lauren, in je stijl van communicatie, habitus, van alles. En ik vroeg me af, hoe zal ze zijn in zo'n formele setting, in zo'n promotie met al die spanningen. En ik kan zeggen, je bent 100% jezelf gebleven. Je bent gewoon zoals je bent, hoe je praat en iedereen vond het fantastisch. Dus gefeliciteerd hiervoor. En nu geef ik het woord aan Hanneke.
Ik ga even mijn papiertje er ook bij pakken. Lieve Lauren, het is me een eer om als tweede jou te feliciteren en dokter Zwienenberg te mogen noemen. En te feliciteren met deze bijzondere mijlpaal in je carrière als wetenschapper. Je kan echt trots zijn op wat je bereikt hebt. En dan wil ik ook graag je ouders en Mike, andere familie en vrienden die hier zijn, feliciteren. Ik vermoed dat jullie al wat trots op haar waren en er komt dit dan nog bij. Een beetje zenuwachtig. Lauren, in 2019 ben je bij ons bij Brain Clinics begonnen en bij Sineda om aan je promotieavontuur te beginnen. En ook aan de Universiteit Maastricht. Een half jaar later heb je je ingeschreven om je traject officieel in te gaan. Toen ben je begonnen aan het onderzoeken van de rol van de connectie tussen het hart en het brein in depressie. Geen persoon is namelijk hetzelfde en daarom is het goed om te onderzoeken of en hoe je een behandelkeuze kan optimaliseren voor een speciale patiënt. Er bestond al bewijs dat die connectie er bestond tussen het hart en het brein met de heart rate decelerations. Maar we hadden nog niet echt een hele goede meetmethode. En daar had Martijn natuurlijk een ideetje voor. De heart-brain coupling. En gelukkig heb jij dat net allemaal uitgelegd, dus dat hoef ik niet te doen. Die kan dus door middel van TMS de connectie tussen het hart en het brein meten. En het is ook nog heel gemakkelijk om te gebruiken in de klinische praktijk, wat je ook hebt bewezen. Om dat verder te ontwikkelen ontstond vrij organisch de Heart-Brain Group. binnen Brain Clinics, samen met Eva aan de rechterhand en René aan de linkerhand. Ik zou haast vragen of jullie nu je toch op een rijtje staat even de heart-brain coupling dansje zouden willen doen. Nee, toch niet. Nou ja, je hebt dus samen aan de wieg gestaan van de Heart-Brain app. Ontzettend veel data verzameld, waar hier geloof ik ook een aantal proefpersonen van aanwezig zijn. Die hem het allemaal mee kunnen maken, tot flauwvallen aan toe zelfs. De app gaf hele mooie resultaten en we konden duidelijk zien wanneer de TMS ook effect had op de hartslag. Tot verrassing van je familie, begreep ik, want je kon toch helemaal geen natuurkunde, ben je naar Oxford getrokken voor een heel technisch onderzoek. Daarvoor mocht je dus naar het Ping Lab in Oxford. Dat was een heel mooie en leerzame tijd, maar ook een heel geworsteld met de dataverzameling. Herinner ik me, waardoor je ook wel hebt leren improviseren in een hele weerbarstige praktijk. Ik herinner me bijvoorbeeld een TMS-coil die de hele tijd oververhit raakte en dan in een koelkast of een diepvries gelegd werd die er eigenlijk helemaal niet voor bedoeld was. Nou, je hebt dus over al dat werk al 2 wetenschappelijke papers gepubliceerd als eerste auteur en er zijn er nog een stuk of 4 onderweg. En dat niet alleen, je hebt er dus ook mede voor gezorgd dat deze kennis gebruikt kan worden in de klinische praktijk. En door jezelf bij Cineda op het moment al en ook bij Neurocare in Nijmegen. Niet veel promovendi kunnen zeggen dat ze al impact hebben op de klinische praktijk. Nou ja, onze andere avonturen, onze reis naar Charleston bijvoorbeeld voor het Brain Stimulation Congres en de roadtrip daarna zal ik ook nooit meer vergeten. Van This is Hanukkah zingen in de auto naar Jacksonville tot salsa dansen in Little Havana in Miami en gillend en geschrokkend wegrennen van een nogal grote alligator in de Everglades. Ongeveer 2 jaar geleden ben je ook begonnen als klinisch behandelaar bij Cineda en door de inleiding en afsluiting van je proefschrift is heel duidelijk dat elke individuele patiënt en wat jij voor ze kan doen uiteindelijk voor jou het belangrijkste is. Dit klinische werk heb je kunnen combineren met je wetenschappelijk werk. En je hebt er een hele mooie balans in kunnen vinden, waardoor je dat nu nog steeds kan blijven doen bij Cineda. En daar ben ik heel blij mee. Ik heb je de afgelopen jaren leren kennen, net als Alex, als een hele spontane, praktisch ingestelde, maar ook inspirerende vrouw. Je staat voor alles open en je gaat het aan, als het is wat je wil. Het feit dat je naast je promotietraject ook nog 2 verhuizingen en verbouwingen samen met Mike aangegaan bent, ja, dat laat wel zien dat je een echte doener bent. Ik denk dat we de afgelopen jaren gewoon heel veel aan elkaar gehad hebben. Ik ook net zoveel aan jou als jij aan mij. En ik ben heel blij dat we collega's blijven bij Cineda. Het volgende avontuur staat alweer op de planning, want in april gaan we naar Toronto, ook weer naar een congres. En ik hoop dat er nog vele zullen volgen. Heel erg gefeliciteerd en geniet ervan.
Yeah, dear Dr. Zwienenberg, also on behalf of Maastricht University, I would like to congratulate you with your degree. And of course, I too include here the promotion team and also your family who stood behind you in this process. Now, before I'm going to use this hammer here, just a practical note, there will be a reception afterwards and the audience can make their way towards it. I would like to ask everyone here in front to stay behind for a photo moment, including our online guests. And also your family is welcome to stay for that moment before you all go have a drink in the rafter. And with this, I'm going to close this academic ceremony.